Hi guys, Audrey here. So today we're going to do one last example of the squeeze theorem. So mostly we see this squeeze theorem involving trig, because most of the time when this -1 to the n shows up, that means that the series is alternating. But that's not actually what's happening in this case. Notice that -1 to the n is there twice, and it's not just multiplied by the whole thing. So this is not an alternating series, but it does have that -1 to the n. So we said that the squeeze theorem is useful when you have something whose limit doesn't exist. So we know that the limit as n approaches infinity of -1 to the n does not exist because it's bouncing back and forth between positive and -1. It's oscillating between -1 and 1. So this actually fits perfectly the idea that we have for using the squeeze theorem. So it's oscillating between -1 and 1, so that limit doesn't exist, but because it's oscillating between -1 and 1, it is bounded, and it's bounded on the bottom by -1 and on the top by 1. So that said, it shows up twice in this thing. So when I'm thinking about the limit of this, the limit as n approaches infinity, 2n plus -1 to the n over 3n minus -1 to the n. Ideally, we're kind of thinking about bounding it. But because that -1 to the n shows up in both the numerator or the denominator, that might be a little bit challenging. So what we're going to do here is we're going to split it up into two different limits. So this is the limit is 2n over 3n minus -1 to the n, plus the limit as n goes to infinity of -1 to the n over 3n minus -1 to the n. All right, so what we're going to do is that first limit looks maybe a little bit easier now since the -1 to the n, the problem, is only there one time. So we're going to separate this. We're going to call this one smiley face, and we'll call this one over here star. So for smiley face, it's pretty straightforward. We are going to start, as we normally start the squeeze theorem, by bounding -1 to the n. So -1 is less than -1 to the n is less than 1. Then we're slowly going to build back up to the thing that we have there. So first I'm going to multiply by -1 since we're subtracting -1 to the n. And that's going to give me 1, and this is going to change the signs, is greater than -1 to the n is greater than -1. Notice we actually end up right back where we started. That's because -1 to the n is just like -1 to the n plus 1. So it's really the same thing. Still oscillating between -1 and 1. Now we're going to add 3n to each of these things. So plus 3n, plus 3n, plus 3n, and that's not going to change our inequalities at all. So I'll have 3n minus 1 is less than 3n minus -1 to the n, I forgot my n up here, which is less than 3n plus 1. That should be an n right there. Okay, now this is in our denominator, so we need to flip the fraction. And remember, flipping the fraction also results in a change in inequality. So this will be 1 over 3n minus 1 greater than 1 over 3n, minus -1 to the n, which is greater than 1 over 3n plus 1. Now I have a 2n on top, so I'm going to multiply each of these things by 2n. And at the same time, I'm going to flip it around so that we have the smallest at the very left. So I'll have 2n over 3n plus 1 is less than 2n over 3n minus -1 to the n is less than 2n over 3n minus 1. Now, if we go and do these limits on the side, we'll call this a and we'll call this b. So a, the limit as n approaches infinity of 2n over 3n plus 1. This is one of those things where we could do L'Hopital's rule, or we could just take our dominant terms and see that this is equal to 2/3. And for b, same thing, the limit as n approaches infinity 2n over 3n minus 1 will also equal 2/3, either by L'Hopital's rule or by just taking the dominant terms. So both of those, A and B, are then going to 2/3. So then I can say that the limit as n approaches infinity of 2n over 3n minus -1 to the n is going to 2/3. Now, this brings us to our second limit. So our second limit we had called star, and what we had was the limit as n approaches infinity of -1 to the n over 3n minus -1 to the n. Now, there are two things to notice about this. The first is that we still have that -1 to the n 2 times, which means that this might be challenging to bound. The second, though, is that because this is now multiplied by -1 to the power of n, we can actually take the absolute value of the limit. If the absolute value goes to 0, we know the whole thing goes to 0. If the absolute value does not go to 0, we know that the limit then does not exist. So when I'm doing the absolute value of this thing, well, on the bottom, I have 3n minus -1 to the n. So that's either 3n minus 1 or 3n plus 1. Either way, that's going to be positive for all values of n that we care about, because we always start with n equals 1 with sequences and move forward. So the only thing the absolute value is really doing here is making that -1 to the n always just be +1. So if I'm looking at this absolute value, this is equal to the limit as n approaches infinity of 1 over 3n minus -1 to the n. Now again, we're going to apply the squeeze theorem a second time. So actually, I'm going to go back up here and write that we did this by the squeeze theorem. We should always state how we do something. So then we're going to apply that squeeze theorem a second time. But I'm going to use the work that I already did. So here I know that 1 over 3n plus 1 is less than 1 over 3n minus -1 to the n is less than 1 over 3n minus 1. So that's just from this line right here. So I'm just kind of repeating that line. Well, then I've bound both of those things already. So this one right here we'll call asterisk, and this one we'll call puppy dog. And asterisk, we can see the limit as n approaches infinity of 1 over 3n plus 1. We can just take the big stuff, the 1 on top and the 3n on bottom, to get 1 over infinity, and 1 over infinity we know is going to 0. So this thing right here is going to 0. And then puppy dog, we have the limit as n approaches infinity of 1 over 3n minus 1, we can see will give us the same thing. We've taken the big stuff there, and we get that this is also going to 0. So what that means is, by the squeeze theorem, this limit right here, n goes to infinity of 1 over 3n minus -1 to the n is going to 0. But then that means that the original thing was also going to 0. So this tells me then, oops, that this limit right here. So the limit as n approaches infinity of -1 to the n over 3n minus -1 to the n is also going to 0. Okay, let's put this all together. So what we had started with was this limit right up here. So we're gonna write our final answer right here, which means that we got that smiley face was going to 2/3 plus star was going to 0. So this thing right here actually equals to 2/3. And therefore my conclusion is that A7, which was equal to 2n plus -1 to the n over 3n minus -1 to the n converges to 2/3 for my final answer. Hopefully you guys were able to follow, and we see that that's kind of a little bit of a more complicated version of the squeeze theorem. We ended up having to use it 2 times in the same problem. Hope this helps. Bye guys.